So this is my second video tutorial on trig substitutions, and in this tutorial we will be looking at substitutions of the type A secant theta. Now as we described before, depending on the nature of the radical, the substitution will change. For example, here we have x squared minus 9 radical, which requires a secant substitution. If I had 9 minus x squared on the other hand, like we did before, we will require a sine substitution, a sine theta. And on the other hand, if you had x squared plus 9, then we would require a tangent substitution, a tangent theta. Because we have x squared minus 9, then it makes sense to try the secant substitution. And then what is a? A would be the square root of the other part, so the something part. So if it is x squared minus something, whatever that something is, the square root of that should be a. So in this case the something is 9, so the square root of that will be 3, so a is 3. You have 3 secant theta. So the first thing that we should do is to find dx, and dx would be if x is equal to 3 secant theta. If you differentiate both sides, you get dx is equal to 3 secant theta. The derivative of secant theta would be secant theta tangent theta d theta. Then what I would do is just go and plug that in up here. So the dx now becomes 3 secant theta tangent theta d theta. Make sure that you make that change, otherwise you might forget to do that later on. And x squared will be 3 secant theta squared, and the square root of x squared minus 9 would be x squared will be 3 secant theta squared, and 3 secant theta squared would be 9. 3 squared is 9, so 9 secant squared theta. So we have 9 secant squared theta minus, of course, we have another 9, and then we have the square root in front of that. So now the first thing that we can do is to try to get the 9 outside the square root, and then that becomes 3, and the rest I will leave as it is. And when you do that, you will see that we have a secant squared theta minus 1. Now is the time to think about the Pythagorean identities. Now if you remember, there is a Pythagorean identity which links the secant squared and the tangent squared, which goes like secant squared theta is equal to 1 plus tangent squared theta. So then if I use that, then secant squared minus 1, so we take the 1 over to this side, then secant squared minus 1 is just tangent squared theta. What I'm going to do is take this tangent squared theta and just plug it up here. So I will leave the rest the same for the time being. So I have this part and this part being the same. And then I have 3. Secant squared minus 1 will be tangent squared theta, so square root of that. Now the nice thing about is that that square root will now nicely simplify. The square root of tangent squared theta is equal to 3 tangent theta. So in all these trig substitution integrals, right, okay, the square root part, the radical part, simplifies very nicely when you put the correct substitution. You may recall that when we had the a squared minus x squared radical and we put x equals a sine theta, it actually is simplified to give a cosine theta. And the same deal with the x squared plus a squared situation. When we put a equals x equals a tangent theta, then it simplified to give secant theta. And now in this case, the radical simplifies to give a tangent theta. So in this case, a is 3, so you get 3 tangent theta. Now things will nicely cancel off, hopefully. And so we have tangent theta cancelling off with tangent theta. We have 3 cancelling off with 3. And then we have secant theta and a secant theta squared here. So one of the secant thetas will cancel off, right? And then you will actually have a so you will have actually 9. So be very careful here. So the tangent cancels out, the 3 secant cancels off, but we have a 3 squared coming from here. So it's really a 9. So the only thing that will be left will be secant squared downstairs, right? Because the secant theta will also cancel with secant theta. So we have secant theta, secant squared theta, which will cancel off to give 1 over secant theta. We have 3 will cancel off with 3 tangent theta, with cancel off with tangent theta. We have a 3 squared, which is 9, and that 9 will remain. All the others will cancel off. Now you have 1 over secant theta, which actually looks a little difficult, but it is really very simple, because 1 over secant theta is nothing but cosine theta. So in there it turns out to be 1 over 9. I'm sorry, I made a stupid mistake there. 1 over secant theta, which is 1 over 9 cosine theta, and the integral of cosine theta is sine theta, so the answer would be 1/9 sine theta plus c. Once again, we need to convert the theta back to x, but we will do that separately because it can be a little complicated, but for the time being, understand what we did. So we learned about how to use a secant substitution, and we do that when we have x squared minus something radical. Like always, we must first try a substitution, but clearly there are no possibilities here for a use substitution. Failing that, we try an x equals x secant theta, and so in this case a would be the square root of the other part. And then the nice thing about it is, once you do that, this junk, this inside, what is inside the square root will nicely simplify, and then the square root will reduce to a tangent theta. That is what we see here, and that's the whole purpose of doing that. Alright, that's it for this example, and now I'm going to give you a video exercise, and that is to evaluate this one, which is very similar to the one that we did. So please write down your answer in a piece of paper and bring it to class on Thursday. Alright, that's it for today. Have a great evening. Thank you.